Good morning. Today we're going to work on smallest number in infinite set. So, you have a set which contains all positive integers 1 through infinity. Implement the smallest infinite set class. Smallest infinite set initializes the set object to contain all positive integers. Int pop smallest removes and returns the smallest integer contained in the infinite set. Add back adds a positive integer into the set if it's not already contained. Okay, so my first reaction is, how the heck am I gonna contain an infinite set? But it's all positive integers, so it is bounded on the left. So pop smallest means there's always going to be a smallest. There will never be a largest because it's infinite, but it is bounded on the left. And I think the solution is not to track what's in the set. If you were to initialize a literally infinite set, you would crash every possible computer. That's how infinity works. But if we track what's not in the set and manage that, then we have something we can work with. So we're going to start the function at contains all. Let's do this. Infinity. Actually, 1 comma infinity. Okay. And then we're going to have some subset which is removed integers. Do that in red, make it large. So when we pop the smallest, we'll start at 1 and check each integer to see if it's been removed already. I think that's the best way to handle that. I don't imagine there's a better way. I wonder if I could increment. Yeah, what if I save? So I could save this is the smallest integer in the set and increment and change it every time pop smallest or add back changes which one's the smallest. But I don't know if it would add anything in this test. Maybe it would, because they do a bunch of pop smallests. So let's see. Yeah, let's track the smallest integer. Smallest equals int, and then we're going to track removed ints equals set. Okay, let's talk about constraints. We know 1 plus. Infinite set equals 1 to infinity. At most 1,000 calls will be made. I don't know if that matters to me. I want it to be as fast as possible in any case. So calls less than equal to 1,000. Edge cases. Pop smallest will start at 1 and increment. Smallest is actually 1, not 0. Smallest starts at 0. Okay, so we're going to initialize self.infinite set, no, self.removed ints equals empty set, and self.smallest equals 1. Now, pop smallest when we pop smallest, we're going to do so first we have to pull the current smallest and set it aside. We're going to return it at the end. And then we're going to increment smallest to the next smallest. So let's set up result equals self.smallest. Okay. And then we need to increment smallest, but if the next item's already in the removed, oh wait, we have to add this to removed ints. So let's do self.removed ints dot add self.smallest. Okay, and then we're going to do a while loop. Actually, let's increment first. Self.smallest plus equals 1. Okay, while self.smallest in remove self.removed ints. We're going to self.smallest plus equals 1. And that's it. Now we return the result. And then add back doesn't return anything, so all I have to do is remove this from removed ints and possibly change self.smallest. So if num is less than self.smallest, self.smallest, oh, wait a minute. Yeah. yeah, I can do it this way because if num is already in the set, then it's either the smallest already or it's not smaller than smallest. So in any case, this will only run if I'm adding a smaller number. And then I will self.removed int dot remove num. Okay, I think that'll do it. Let's run the test. What did I mess up? Self.smallest, undetermined literal. Oh. Okay. Tuple object has no... What? Since when is num a tuple? Oh. This should be set, not an empty tuple. Duh. Key error. Really? Let's check out Python sets. Sets. Okay, set. Oh, how does this work? We need remove element. Raises a key error if it doesn't exist. Okay, so I just need to check if num is in. If num in self.removed int then remove. And successful. Run the test. Boom! Beats 54%. I'm surprised. Yeah, I figured I would have done better than that. Let's see, what did the masters do? They did the same thing, got a current and a new set. If self.s exists, result equals the minimum of self.s, and then remove the result. Interesting. If self.current is greater than num. Oh. Okay, they're tracking just the ones that are above the minimum. the current minimum. That makes a lot of sense. Okay, well, thank you for joining me.